Okay, this is the theory for exercise 7.7, intersection of lines. Now, in this exercise, we'll look at three things: intersection of lines, how to find the intersection of two lines, how to show that three lines are concurrent, and also how to find the equation of a line passing through the intersection of 2 points and another point. So first we'll just start off looking at how to find the point of intersection of two lines. Now, if two straight lines intersect at point xy, then the point xy, so for example, if we've got two lines and that they intersect at this point xy, okay, then what we know is that both lines pass through this point xy, or in other words, xy, the point xy satisfies the equations of both lines. Now, what we mean by satisfies the equations of both lines is that once we've found the point xy, if you substituted the point xy into either of the two lines, either of the equations of those two lines, or into both of them, that it would satisfy it. So you would get both sides of the equation equaling the same thing, okay? Now, the way that we find the point of intersection of two lines is to solve the two equations simultaneously. Now, here's our first example. Find the point of intersection of the lines 8x minus 7y minus 3 equals 0. That's the first line, and this second line, 5x minus 2y minus 1 equals 0. So we're finding the point of intersection of these two lines, so we'll just call that equation 1. This other line here, 5x minus 2y minus 1 equals 0, is equation 2. Now we can see that the coefficients of the x and the coefficients of the y's are not the same. We can decide to make the coefficients of the x's either the same or the y's the same. I think I'll make the coefficient of the y's both the same here, so I'm going to multiply equation 1 by 2. Because we're going to make the coefficients of both these y's into 14. So equation 1 times 2 would give me 16x minus 14y minus 6 equals 0. I'll call that equation 1a because it came from equation 1. And we'll look at equation 2. How we're going to make this 14y, we'll do equation 2 times 7. And we will get 35x minus 14y minus 7 equals 0. I'll call that equation 2a. Now that the coefficients of the y's are the same, we're going to, if these two were the same, if they're the same, for example, if it was 5y and 5y, you would subtract them, because if you've got something and you subtract the identical thing, it goes away. Now, don't try and add these two together. You need to subtract them, because if you add them, you'll get negative 14y minus negative if you add them, you'd get negative 14y plus negative 14y would be negative 28y. So adding those two together will give you negative 28y. So what you need to do is do equation 1a minus equation 2a, or you can even do it the other way around. I'm actually going to do it the other way around. So equation 2a minus equation 1a. The reason I'm going to do that is that I want my coefficient of x to be positive. So if you subtract these two, you'll get negative 14 minus negative 14, which means negative 14 plus negative 14 gives you 0. Or you look at it and you say those two are identical in sign and in magnitude. So you subtract two things that are the same to get 0. So what I said I was going to do, sorry, I just need to cancel that. So what I said I was going to do is that we're going to do equation 2a minus equation 1a. So 35x minus 16x, so 35 minus 16 is 19x. And then negative 14y minus negative 14y is negative 14y plus 14y, which is 0. Then we've got negative 7 minus negative 6, so that's negative 7 plus 6, which is minus 1, equals 0. And we get that 19x equals 1, or x equals 1 on 19. Okay, so this is not a whole number. You don't need to worry about that, just checking that we've done everything correctly. And it looks like we have. So we've got x equals 1 on 19 now. To solve simultaneously, we're going to substitute that point x equals 1 on 19 into any of these equations. I'll just put it into equation, let's try equation 2, so sub into equation 2, I'm going to get 5 times 1 over 19 minus 2y minus 1 equals 0. Let's take this 2y to the other side. We'll get 5 on 19 minus 1 equals 2y. Now 5 over 19 minus 1 over 2, so y will be, so we've got 5 over 19 minus 1, which is 5 over 19 minus 19 over 19. That's negative 14 over 19. That's what 2y is. So 2y is negative 14 over 19. Now dividing that by 2, we get negative 14 over 38, and that can be simplified to negative 7 over 19. Okay, so that's the solution to that equation. So therefore the point of intersection is 1 on 19, negative 7 on 19. Sorry, that's run off the page. Okay, so that is the point of intersection of those two lines. Now for the same exercise, we're looking at concurrent lines. Now concurrent lines are 3 or more lines that meet or pass through a single point. Now to show that 3 lines are concurrent, these are the steps that we take. We solve 2 simultaneous equations. So for example, let's say this is line 1 and this is, say, line 2. We find the point of intersection of those 2 lines, and that will be that dot there. And then what we do is, once we've got this point of intersection xy, we show that xy lies on the third line, line 3. Okay, so we will solve the the 2 simultaneous equations to find their point of intersection xy, and then that point of intersection xy, we will substitute it into the equation of the third line to show that it satisfies the equation of that line, and if it satisfies the equation of that line, therefore it lies on that line. Okay? Okay, here's our first example. We have to show that these 3 lines, x plus 4y plus 5 equals 0, 3x minus 7y plus 15 equals 0, and 6x plus 5y plus 30 equals 0. We have to show that those 3 lines are concurrent. Okay, so what we will do is we will first find the point of intersection of 2 of those lines. So here we've got our first line, x plus 4y plus 5 equals 0. I'll call that line 1. And line 2 is 3x minus 7y plus 15 equals 0. So that's line 2. Now, to find the point of intersection of these 2 lines, we need to solve these 2 equations simultaneously. We can do this a number of ways. We can rearrange the first equation to make x the subject and substitute that in there, or we can just make the coefficient of this x here 3. So I think we'll just do that. So we'll do equation 1 times 3, and that will give us 3x plus 12y plus 15 equals 0. So we're multiplying equation 1 by 3, and I'll call that equation 1a. So now we can work with equations 1 and 2 because the coefficient of x of both of those equations is identical. So we want to subtract these 2 equations, but I'm going to do equation 1a minus equation 2 because looking at the coefficients of the y's, if I do this equation here minus this one, I'll end up with a positive coefficient of the y. So 3x minus x is 0, 12y minus negative 7y is 19y, and I've got 15 minus 15 is also 0. So that gives me 15 minus 15 is 0, so I get 19y plus 0 equals 0. In other words, y will have to equal 19y is 0 or y equals 0. Now, I'm going to substitute y equals 0 into any of these equations. I think I'll substitute it into equation 1. And if y is 0, I will get x plus 4 times 0 plus 5 equals 0. So I get that x plus 5 is 0, or that x is negative 5. Therefore, my point of intersection of those 2 lines is the point negative 5, 0, because remember, a point has an x value and then a y value. So that's the point of intersection of these first two lines. Now to show that this third line, 6x plus 5y plus 30 equals 0, also passes through the point of intersection of these two lines, we're now going to substitute the point -5, 0 into the equation of this third line, into 6x plus 5y plus 30 equals 0. And if this point -5, 0 satisfies that equation, then that means that that line passes through that point as well. So we're going to substitute this point in. So we go 6 times the x value, or 6 times -5, plus 5 times whatever the y value is, which is 0, plus 30 equals 0. I'll just work this out over here. I've got -30 plus 0 plus 30 is 0. Looking at my left-hand side, -30 plus 30 is 0 equals 0. Therefore, that's true. Therefore, -5, 0 lies on the line. 6x plus 5y plus 30 equals 0. Therefore, the three lines are concurrent. In other words, the three lines all pass through that same point, that point being -5, 0. And that's how you do a question like this, okay? Okay, now, the last part of this exercise 7.7 is how to find the equation of a line through the intersection of two other lines and another point. So, to find the equation of a line through a point and the intersection of two other lines, this is what we do. We find the point of intersection of the two other lines using simultaneous equations, and then we find the equation of the line used through this first point here and the point of intersection of the other two lines. So in other words, we're now just finding the equation of a line passing through 2 points. And we'll do that by first finding the gradient of the line, joining those 2 points, and then using the point gradient formula. So here is an example here, okay? So we have to find the equation of the line passing through the point 3, 2, and the intersection of these lines, 5x plus 2y plus 1 equals 0, and 3x minus y plus 16 equals 0. So what we're going to do, we're going to find the point of intersection of these two lines first. So there's line 1, 5x plus 2y plus 1 equals 0, and here is line 2, 3x minus y plus 16 equals 0, that's line 2. Now we need to solve these equations simultaneously. What I'm going to do, I'm actually going to rearrange equation 2 to make it y equals 3x plus 16. So I'm going to write rearranging. We get that, and we're going to substitute that into equation 1. So we're rearranging equation 2 to give that, to give y equals 3x plus 16. We're going to sub that into equation 1. So we get 5x plus 2 bracket whatever the y is, which is 3x plus 16, plus 1 equals 0. We get 5x plus 6x plus 32 plus 1 equals 0, or 11x plus 33 is 0, or 11x is -33, in other words, x is -3. Now we're going to substitute x equals -3. I think we'll do it into this one. I'll call this equation 2a, because it's just rearranging equation 2. I'm going to substitute x equals -3 into this equation 2a, which is y equals 3x plus 16. It can be substituted into any of these, but the easiest would be into this, because you've already got y as the subject of the formula. So we get y equals 3 times -3, because that's what x is, -3 plus 16. So it's -9 plus 16, which happens to be 7. Therefore, my point of intersection of the two lines is -3. So my point of intersection is -3, 7. So remembering what the question is, the question says find the equation of the line passing through the point 3, 2 and the intersection of these two lines. Now the point of intersection of those two lines is -3, 7. So what I really want now is the equation of the line through the points 3, 2 and -3, 7. So the question now has just become that. Now as I've explained in or requested in other exercises, if you're asked to find the equation of a line through 2 points, I prefer to find the gradient of the line through those 2 points and then use the point gradient formula. Reason being is that you have to learn enough equations as it is. So I'm going to find the gradient of the line joining those 2 points. Remember, the gradient formula is y2 minus y1 over x2 minus x1. So that's y2 and y1. So we'll go 7 minus 2 over negative 3 minus 3, which is 5 over negative 6. So that's the gradient of the line joining those 2 points. And so the equation of the line joining those 2 points, I'm going to use the gradient, negative 5, 6, and I'm just going to use one of those 2 points. I might just use the first one here. So for the equation of the line, I'm going to use the gradient, negative 5 sixths, and the point 3, 2. So we're going y minus y1 equals mx minus x1. Now, whether you use the first point 3, 2 or the second point negative 3, 7, you will get the same equation in the end. So we go y minus y1 in this case is 2. So this is x1, y1 equals m, which is negative 5 on 6. X minus x1 is 3. Now, what we need to do is get rid of this 6 down the bottom, and to get rid of this, divide by 6. We times by 6, so we go 6 bracket y minus 2 equals negative 5 bracket x minus 3. So just expanding that, we get 6y minus 12 equals negative 5x plus 15. Now we need to put this into general form, as these are here. And the coefficient of the x here is negative, so we need to take everything over to the left. And when we do general form, the x term comes first, so we get 5x over here, then the y term plus 6y. Now we've got negative 12 over here, and we're bringing this 15 over, so we'll get negative 12 minus 15, which is minus 27, equals 0. So that is the equation of the line passing through the point 3, 2, and the intersection of those two lines. Now there is another way of doing this question. So there is a second method that does use a special equation, and I'll show you that now. I do tend to just use this method here, where we find the point of intersection of the two lines and then find the equation of the line through those 2 points. However, you may choose to use the equation method. So I'm going to show you that now, and that's method 2. Okay, so method 2, to find the equation of a line through a point and the intersection of two other lines, this is what we do. We have to use this equation here. So to find the intersection of a line, well, I actually meant to write here the equation of a line, so I'll just get rid of that. So to find the equation of a line through a point and the intersection of two other lines, we can use the equation below. So if this line here, a1x plus b1y plus c1 equals 0, and this second equation, a2x plus b2y plus c2 equals 0, are two given lines, then the equation of a line through their intersection is given by this formula. Now notice it's just the first equation plus k times the second equation equals 0, where k is a constant. Now when you write this equation up, so you basically write the two equations up, what we'll do is we'll substitute the point that we're given into the xy to solve for the k, etc. Okay. Now I think it's just best that I do an example, one or two examples here to show you how this works. So example 4, we're doing the same question as example 3, but we're using this method instead. Okay. Now from example 3, I can see the answer. We'll compare our answer to that one in a minute. Okay. So find the equation of the line passing through the point 3, 2 and the intersection of the two lines 5x plus 2y plus 1 equals 0 and 3x minus y plus 16 equals 0. So what we do, we set up this equation. So we write the first line, 5x plus 2y plus 1 plus k times this second equation, 3x minus y plus 16 is equal to 0. So that's what it's telling us to do up there. So if you've got these two lines, and the equation of the line through their intersection is given by this. So you write the first equation plus k times the second equation equals 0, and we've done that. Now, we have to work out what k is. But to work out what k is, we're going to need to substitute a point for x, y. So what we do is we substitute, because this line passes through the point 3, 2, we substitute the point 3, 2 for your x and y values, because this equation here passes through the point 3, 2. So let's do that now. So we go 5 times, here's my x, so 5 times 3 plus 2 times the y value, which is 2, plus 1 plus k times, now 3 times 3 is 9. Wait a sec, just fix that up. And then we get minus whatever the y is, so minus 2 plus 16 equals 0. So I should have just worked this first one out anyway. So 15, we've got 15 plus 4 plus 1 plus k times all of this. So 9 minus 2 is 7 plus 16 is 23 equals 0. So we get 15 plus 4 plus 1. That's 20 plus 23k equals 0, which gives us that k is negative 20 over 23. So now that we've worked out what k is, we substitute it up into this first equation. So we get 5x plus 2y plus 1 plus whatever k is, so it's plus negative. So I'll just write minus 20 over 23. So we've just substituted for this k, times 3x minus y plus 16 equals 0. Now what we need to do is get rid of this 23. So we need to multiply both sides by 23. So we've got a few things here. Remember, this is 3 different terms here. So this whole thing is our first equation. It needs to be multiplied by 23. So we've got 23 times all of that. When we multiply, this is just really one term here. When it gets multiplied by 23, I just lose this 23 off the bottom, and I'm left with that whole numerator there. So I've got 23 times 5x plus 2y plus 1 minus 20 times 3x minus y plus 16 equals 0 times 23, which is 0. So I'm timesing this by 23, this second term by 23, and this by 23. Now 23 times 5 is 115x, plus 23 times 2, that's 46y, plus 23 times 1 is 23, minus 20 times 3x is 60x, plus 20 times y is 20y. 20 times 16 is minus 320 equals 0. Now 115x minus 60x is 55x. 46y and 20y is plus 66y. 23 minus 320 is minus 297. Now that equals 0. Okay, I think this can all be divided by 11 by looking at the 55 and the 66. So dividing everything by 11, we get 5x plus 6y. Now 11 into that goes 2 times, trying to work that out, 77, it goes 27. So 297 divided by 11 is 27. So we get 5x plus 6y minus 27 equals 0. Oops. Sorry, I just went off the page there. So just showing you that working out there. Now that is identical to the answer that we got in example 3, which was exactly the same question. So here, just got to be careful here. This can get a little bit messy. You may use this method if you wish. So it's just basically putting in the first equation plus k times the second equation equals 0. You then just substitute that point of intersection in for the x, y values, work out the k value, put it back in. You'll need to get rid of the denominator here by multiplying through by 23 and solving that equation, just noticing that the numbers here can become quite large. Okay, here is another question here. And we have to find the equation of the straight line with gradient 3 that passes through the intersection of these two lines. So if we look for the point of intersection of these two lines, we'll end up with a point, and then we basically want the equation of the line with gradient 3 passing through the point of intersection of these two lines, so we'll just use point gradient formula. So let's start with the point of intersection of these two lines. We've got 2x plus y minus 1 equals 0, that's equation 1, and the second line is 3x plus 5y plus 16 equals 0, that's equation 2. Now we can make the coefficients of both equations the same, or we can just rearrange equation 1. I'm going to rearrange equation 1 and then just substitute. So rearranging equation 1, we'll get that y equals negative 2x plus 1. We are going to sub that into equation 2. So subbing y equals negative 2x plus 1 into equation 2, we will get 3x plus 5 times negative 2x plus 1 plus 16 equals 0, which gives me 3x minus 10x plus 5 plus 16 equals 0, and that gives me minus 7x plus 21 is 0, which gives us that 7x is 21, therefore x is 3. Substituting x equals 3 into, I'm going to sub that into y equals negative 2x plus 1, and we will get y equals negative 2 times 3 plus 1, which is negative 6 plus 1, which is y equals negative 5. So therefore the point of intersection of those two lines is the point 3, negative 5. So now we just have to find the equation of the straight line with gradient 3 that passes through the point 3, 5. So we've got our gradient is 3 and our point is 3, negative 5. So we just use the point gradient formula for the equation. Okay? And so we get that y minus negative 5 equals gradient 3, x minus this x point here, which is also 3. So we get that y plus 5 equals 3x minus 9. Notice these two equations are in general form, so our final equation should be in general form. We get that 3x minus y, so the coefficient of the x is positive here. So keeping all this over here and bringing these two terms here over, we get 3x minus y. Now I've got minus 9 already and another minus 5, which is minus 14 equals 0. And that is the equation of the straight line with gradient 3 that passes through the intersection of these two lines. So that's my answer. Okay, just one more example using that new equation method. So find the equation of the straight line through the point 3, negative 2 that passes through the intersection of these two lines, 5x plus 2y minus 13 equals 0, and x minus 3y plus 11 equals 0. So remembering that the method is to write the first equation. So 5x plus 2y minus 13 plus k times the second equation equals 0. Okay, so the equation of the line through the intersection of these two lines is that. So that's the equation of the line. Remembering we have to work out k, so we're going to substitute, because this point, this line, this equation passes through the point 3, negative 2, we substitute 3, negative 2 for the x and the y values in that above equation. So we get 5 times 3 is 15, plus 2 times negative 2 is minus 4, minus 13. So I've substituted into there, plus k times, now we're substituting 3 and negative 2 for the x, y values. So x is 3, then we get minus 3 times negative 2, which is plus 6. Then we've got plus 11 equals 0. Now 15 minus 4 is 11. 11 minus 13 is negative 2, plus k times, we've got 3 plus 6 is 9, plus 11 is 20. So we've got now that 20k equals 2, in other words that k equals 2 on 20 or 1/10. So the equation becomes 5x plus 2y minus 13 plus 1 on 10 bracket x minus 3y plus 11 equals 0. So this is our equation. By substituting this 0.3, negative 2 for the xy values, we've worked out k. Now substituting k back in. Now we just need to get rid of the denominator 10. Now this was the first equation there, so we're going to multiply everything by 10. So we get 10 times all of this, plus, if I multiply this by 10, I lose the 10 on the bottom, so I go plus 1 times all of this equals 0 times 10, which is 0. Okay, so now just expanding that, we get that 50x plus 20y minus 130 plus x minus 3y plus 11 equals 0. And I get 50x plus x is 51x. Then I get 20y minus 3y is minus 17y. Then we get minus 130 plus 11 is minus 119, and that equals 0. Now I need to see if I can divide that by anything, and I don't think it's divisible by 3. It might be divisible by 17, so I think I'll try that. Now dividing that by 17, we get 3x minus y minus 7 equals 0. So that's the equation of that line. Okay, our answer is 3x minus y minus 7 equals 0, because we divided all of these terms here by 17. Okay, I'll now set your work for exercise 7.7. If you could please look at doing exercise 7.7, and I'll just write those questions out in a minute. Okay, now your homework for exercise 7.7 is to do question 1, H and I, and questions 4, 6, 7, 17, 20 and 21. That's the end of exercise 7.7. The next video will be exercise 7.8, perpendicular distance of a point to a line.